Hi, I'm Rutger Dankers. I work for the Met Office Hadley Centre. So what is permafrost? Permafrost is soil that remains frozen throughout the year. This mostly happens in cold climate regions such as Alaska, Canada and Siberia. And what happens is if you start to dig a hole in the ground in these areas, even in the middle of summer, even if it is 30 degrees outside, you will find that at a certain depth, maybe half a meter or 1 meter, the soil is still frozen. And if the soil remains frozen throughout the year, we speak about permafrost. And this layer of frozen soil can be hundreds of meters deep, and it is thought that some of the permafrost has been frozen for at least tens of thousands of years. Well, the presence of permafrost has, first of all, important local effects. If you have frozen soil, this usually provides a very stable foundation for infrastructure such as pipelines, railroads and buildings. So if the permafrost were to disappear, some of these infrastructure will either face subsidence or even collapse. Moreover, in mountainous regions, slopes may become unstable and it may lead to landslides. However, the reason why we are mostly interested in permafrost is because it can also have important global feedback effects. There's a lot of organic material in permafrost soils, and how much exactly is still unknown, but it is thought that at least twice as much carbon is stored in frozen soils as is currently present in the atmosphere. If permafrost is going to fall, some of this organic material will start to decompose, and this can either be in the form of CO2, or if it is happening under wet conditions, for example in peatlands, it can also be in the form of methane. Now, methane is a very powerful greenhouse gas, although it remains only in the atmosphere for a short period of time. Nevertheless, the feedback effects may be felt globally if permafrost is going to disappear. What is going to happen with permafrost under climate change? Well, the basic picture is really quite straightforward. Almost all model simulations project that a large part of the permafrost in the Northern Hemisphere, if not most of it, will start to disappear by the end of this century. However, some of the deeper permafrost may take decades, if not centuries, to disappear. And of course, in nature, things are never really very straightforward, because there are also several other important factors. One of these is snow. Snow usually provides a very good protection for the soil against very cold winter temperatures. So if there's more snow in winter, it may actually warm up the soil. However, the opposite is also true. If we have less snow in winter, it may actually cause the soil temperatures to cool down. And then there's vegetation. Most of the permafrost currently occurs in tundra areas, and it is thought that some of these areas will be replaced by forest areas. But we don't really know how fast this will be happening, and we also don't really know how much of the carbon in the permafrost will start to decompose and whether this will be in the form of CO2 or methane gas. So what would I want somebody looking at this map to understand? Well, I think it's important to realize that climate change will be largest at northern high latitudes. So a global warming of 4 degrees means a much more warming in these areas. And although not many people may be living there, the feedback effects may be important globally.